In this example, we are given that a body is released from rest from top of a fixed spherical surface such that it starts sliding down. We are required to find the acceleration of body when it is at a position at an angle 30 degree from the initial position. Let us first draw the physical situation. We are given that there is a spherical surface. From the top of the spherical surface, we are given that a body starts sliding down. It starts sliding down, that means if we can consider its initial speed is 0. As it comes down, because of work done by gravity, its speed will increase. Say the radius of this surface is r, and when the body travels up to a position where the radius makes an angle theta from the vertical or initial position, we can say the body will be having a speed v. And in this situation, from initial to this position, the body has fallen by distance h, and the value of h we can simply write as r minus r cos theta. So in this situation, it is r into 1 minus cos theta. And by work energy equation, we can say that whatever work is done by the gravity in moving the body from this point to this point, that will be the gain in kinetic energy. So here we can write mgh, that is mg r into 1 minus cos theta, is equals to half mv square. Here m gets cancelled out and the speed will get is root of 2gr 1 minus cos theta. This you can directly get by writing v is equals to root 2 gh by energy conservation. So we will directly get this expression. Now at this position, if we just see the normal reaction acting on it is n, it will experience a force, gravitational force in downward direction, that is mg. This angle is say theta. We are required to find the acceleration of body when it is at a position at an angle 30 degree from the initial position. So if theta is 30 degree, we can say in this situation the normal reaction plus the centrifugal force on it is equal to mg cos theta or mg cos 30. But we don't need to use those relations. If we just talk about acceleration at this point, so we can simply say normal acceleration at point P, say this point we denote by P, is, we know very well that normal acceleration we write as v square by r. On substituting the values, we will get it 2g, r gets cancelled out, it is 1 minus cos 30 degree. So the result will get is cos 30 we can write as root 3 by 2. So this can be written as 2g into 1 minus root 3 by 2, which can be written as g into 2 minus root 3. This is the normal acceleration of the body at point P. And we can see this weight is acting on it in downward direction, and there will be a tangential component of this weight, that is mg sin theta, that will be experienced by the body along the tangent. So we can simply state the tangential acceleration at point P is, about this body if we talk, this tangential acceleration can be simply written as mg sin theta upon m. So this will be g sin theta. Now if we put the value of theta, that is 30 degrees, so it comes out to be g by 2. And if we talk about the total acceleration, we can simply state total acceleration of body, A total can be written as root of A tangential square plus A normal square. When you substitute the values, it is root of A tangential square is g square by 4 plus A normal square will be g square into 2 minus root 3 whole square. If we just simplify it, we can see this will be g, we can take simply common out, and the remaining factor will be getting is 1 by 4 plus 2 minus root 3 whole square. So this will be 4 plus 3 minus 2 root 3. So this will give us a value root of 1 by 4 plus 4 plus 3 minus 4 root 3. So this will be the answer to our problem.